So we're factoring today. We're moving into finding the greatest common factor and the least common multiple. Those are a lot of words you may have heard in elementary school, but you've just not seen in a while. So today we're going to be learning how to factor, okay, what that actually is. And we want to make sure we're applying those sharp multiplication skills that we reviewed earlier in the school year. So let's go ahead and get started. Miss Neville's about to go on. So the first question we have is, what is factoring? Please write that question in your notes. What are factors? I'm sorry, wrong question. What are factors? Instead of me writing out a definition for you, let's get right into the nitty-gritty of it. We need to understand that a factor is what we see in a multiplication problem. So factors are 30 and 50. These are called factors. They're actually factors of 1,500 or 1,500. 1,500, this is called a multiple. Okay? So we need to understand that factors are the numbers that we're multiplying, and a multiple is the product or the answer to a multiplication problem. A really easy way that Miss Neville always remembered it when she was in 6th grade math is that multiples were always going to be larger than their factors. Multiples are going to be larger than their factors. Okay? Another example, and someone cut their mic on and tell me, this is an easier one. 2 times 3 equals 6. Someone cut on their mics and tell me, what are the factors here?
2 and 3.
Very good. Thank you, Jalen. 2 and 3 are our factors. So that would make 6 a what?
Multiple.
Multiple.
Very good. Thank you. Let's go ahead and get that in our notes. And then Miss Neville's going to go on. Okay, so let's go on here. So we're going to write down in our notes. Let's get right into the nitty-gritty. We're going to be able to factor or find the factors of a multiple using something called factor trees. And even when you look at these even look like trees, but instead of leaves, they have numbers. So go ahead and write down our first example, A. What we see at the top here is our, starts with an M. What would I call this, guys?
Multiple.
Yep. This is my multiple. So I want to make sure I label it. Sorry for the cruddy handwriting. And this is an easier factor tree because Miss Neville's filled in some of the numbers for you. So when we identify with a factor tree, we want to identify the biggest factors first. And at the very end, at the very bottom of our factor tree, we're going to see smaller numbers there. A lot of 2s and 3s usually. So when we're looking at 30. We're basically doing an algebra problem now. 30 times, or what times 3, what number times 3 will equal 30?
10.
10. So that factor tree tells me I need to keep going smaller. And 2 times what will equal 10?
5.
5. And then this arrow here tells me to bring that 3 down. So these numbers here that are at the very bottom are prime numbers. That means, guys, they have no factors for themselves other than their own number and 1. Okay? So the numbers at the bottom of my factor tree should always be prime. That means their only 2 factors are themselves and 1. They have no other factors. I'll give you a second to write down letter A. And then I want you to go ahead and take some time to write down B and start solving it if you'd like. Miss Neville will use a different color for B, a dark blue. So we see 63, because we're just learning this, or we're learning this after a long time of being rusty, not seeing it since elementary school. We want to make sure we label our 63 as our multiple again. And here's our algebra problem again. 9 times blank, 9 times a number equals 63. What number would go in this bubble?
7.
7. Notice I brought that 7 down. Why did I bring that 7 down? Someone? Starts with a P. 7 is a
prime number.
Very good. 7 is a prime number. So it comes directly down here. Is 9 prime? In other words, does 9 have any other factors?
Three times 3.
3 and
Yes.
3 and 3. So remember, we've got 3 more prime numbers here at the bottom. And to always check to see if if you've created your factor tree correctly, you could really multiply these 3 numbers here at the bottom, and you should get the multiple up top. In other words, if I multiply 3 times 3 times 7, my product would be 63. That lets me know I've completed my factor tree correctly. Go ahead and finish writing down 3. Start writing down C. And start completing that one on your own. I'll be calling on a non-volunteer to help me complete this factor tree. So that means everyone needs to be working here. Okay, Isaiah, turn your mic on for me, please. 27, Isaiah, is my...
27 is your
Starts with an M.
multiple.
Multiple. So I want to make sure I label that as my multiple in my own notes. Isaiah, then I need to find out my first two factors here for 27. In other words, 3 times a number
9.
27. Very good. 9. Isaiah, why am I bringing this 3 down here?
Because it's your prime number.
It's a prime number. Is 9 prime, Isaiah?
Yeah, I think so, yes.
So the only factors for 9 are 1 and 9?
Yes. It's an odd number, so there's no equal to 9 because 4, 8, 2, 4, 6, 8. Oh, 3.
3. Very good.
You can multiply 3 and 9.
Yeah, so 3 times 3 will multiply to be 9. So 9 is not prime, Isaiah. The opposite of prime is a composite number. The opposite of prime is a composite number. A composite number is a number that has more than 2 factors. Thank you, Isaiah. You may mute yourself.
Okay.
Go ahead and finish writing this down. Remember, the way that we're able to check ourselves, the way we're able to check to make sure we completed our factor tree correctly, is that if I wanted to multiply 3 times 3 times 3, that I would find that it's 27. My product would be 27. So let's get into the nitty-gritty here. Now let's start doing our own factoring with less help from Miss Neville. Remember, I'm recording this lesson. So if I'm going too fast for you during whole group, it's going to be important that you watch this video when I post it on Schoology in about 10 minutes so that you can get any notes or listen to anything that Miss Neville had said again. So let's look at examples 1, 2, and 3. Ms. Neville's helping you out a little bit here. And this time I'm going to use my orange. And is 45 a multiple? Yes or no? Turn on your mic.
Yes.
Yes. 45 is our multiple. Another question, turn on your mic. Is 45 prime or composite?
Composite.
Composite. It has more than 2 factors. So I want to make sure I wrote that in my notes under or around 45, just so we can understand how we're describing 45. So let's look at our first 2 factors. What will be the first number that goes in this bubble? A number times 5 equals 45. What would that number be?
9. 9.
Very good. I'm going to bring 5 down. Why am I bringing 5 all the way to the bottom?
Because it's a prime number.
It's prime. Very good. All the numbers at the bottom will be prime. Okay? So, remember me and Isaiah just talked about how 9 is not prime, 9 is composite. So what are 2 other factors? What's another factor for 9? Can someone tell us?
3.
3. Actually, it's 3 times 3. How do I know that I've done my prime factorization tree correctly?
You can multiply all the numbers that are at the bottom.
Very good. Very good. Let's start working on example B. And if you're waiting for your classmates, you can go ahead and start solving ahead of us. Miss Neville's going slow because a lot of us, this is our first time seeing this in a long time. Okay? So, how would I describe 18? What are two words I would use to describe 18? It's going to start with an M, and it's going to start with a C.
Multiple and composite.
Yeah. So I want to make sure I write that in my notes. You should be too. What are the two factors of 18? 3 and
6.
I'm going to bring my 3 down. Orlando, turn on your mic and tell me, why am I bringing my 3 down to the bottom here?
Because it's a prime.
Very good. It's a prime number. Okay. Josiah, could you tell me what number is going to go in this middle bubble?
3.
Very good. And so I know I've done this right if, Melena, how do I know if I've done this right?
You can multiply all the numbers.
Very good. And what would my product be when I multiply those 3 numbers, Melena?
18.
Very good. All right, let's start doing C by ourselves. And Miss Neville will call on a non-volunteer to help the class complete it. Let's complete C, please. We're working on C. Jordan, turn on your mic, please, and tell me what 2 words would I use to describe 28?
Multiple and composite.
Very good. Jordan, keep your mic on. What number would go here in this first bubble?
7.
Very good. Jordan, what am I going to do with that 7?
Bring it down.
Why?
Hold on.
Remember, all numbers at the bottom of the tree are
Prime.
prime. So 7 is prime, so I would bring it down. Jordan, what 2 other numbers would join 7 at the bottom of our tree? In other words, what 2 numbers multiply together to give me 4?
4 and 1.
Well, it couldn't be 4 and 1 because 4 isn't prime, it's composite.
Wait, never mind. 2 and 2.
Very good. 2, 2, and 7 should be here at the bottom. And Jordan, how do I know if I've done this correctly?
To see if all of the numbers on the bottom are prime.
Yep, they'll be prime. And also when I multiply them together, what number would I get? What product would I get?
$28.
Yep. So I will get that number in the top of my top multiple. That's the number I'd get there. Where's Miss Neville's little one? There it is. Yep. And so I would know I've done this right if 2 times 2 times 7 equal 28, which it most definitely does. Great job, guys. So here's what I need you doing today. You're going to move on into your independent practice in Schoology. Ms. Neville's about to publish it for you. Before I publish it, I want to show you how to get there. Okay, so we're going to our Schoology, into our math folder. We're going to now be moving into a red folder that says finding the greatest common factor and least common multiple. And the first assignment that you're going to be working on today is finding the greatest common factor. Finding the greatest common factor. The worksheet is going to help you realize what common factors are between two numbers. And then you're going to work to not only identify the common factors between two numbers using the same process we just did, but you're also then going to find what their greatest common factor is. What's the largest factor that both of those multiples have in common? This will be a graded assignment. However, if you don't do well on this assignment, it just lets Miss Neville know you need more help. And so tomorrow you'll be in my small group with finding the greatest common factor. If you have any questions, please email me. If I could please have